Hi, my name is Afsaneh Razi and I'm a computer science PhD candidate at the University of Central Florida, working with the supervision of Dr. Pamela Wisniewski. I'm happy to present our work, a human-centered systematic literature review of computational approaches for online sexual risk detection. The Internet has the potential to facilitate new friendships, but it also has been used to commit sexually based harm. 2020 was a record-breaking year, with more than 21 million reports of suspected child sexual exploitations made to the National Center of Missing and Exploited Children. This marks the highest number of reports ever received in 1 year. Given the prevalence of Internet-based sexual violence, the relevance and applicability of machine learning approaches for online sexual risk detection has become of critical importance when considering solutions for solving this dire societal problem. Past research has expressed concern about these artificial intelligence systems failing to account for limitations or uncertainties inherent in their predictions that may result in negative impacts to people's lives. Therefore, using human-centered design enables researchers to incorporate the perspective of various stakeholders, helping them to construct a robust algorithm. Therefore, we created a human-centered framework to conduct this literature review, which is one of the contributions of this work and also serves as a theoretical lens for grounding the analysis of the reviewed papers. Traditional frameworks of computational machine learning risk detection has been focused on data, models, and computational evaluation of the models. Yet, we used the human-centered lens that led us to ask more nuanced questions. First, are the datasets ecologically valid for detecting the targeted risk for the desired user population? Are the algorithms grounded in human theory, understanding, and knowledge? How well do the algorithms perform computationally and in meeting end users' needs? And lastly, we are interested to know what system artifacts are developed and what were the outcomes when deployed in real-world setting. We performed a comprehensive literature search in various digital libraries to identify any potential approaches for online sexual risk detection. Our literature review, we broadly considered all types of online sexual risks that may result in mental or physical harm. We considered peer-reviewed articles published between 2007 and 2020 on computational approaches utilizing text, metadata, or multimedia for online sexual risk detection, which led us to 73 articles. We leveraged the human-centered lens proposed to qualitatively decode the 73 relevant papers. Our final codebook is presented in this table. We use an iterative process to refine our codes and allowed codes to overlap and be double-coded. 3 coders labeled the same 15% of articles, and we calculated inter-rater reliability, which resulted in a substantial to a complete agreement. We identified sexual grooming, sex trafficking, and sexual harassment or abuse as the 3 types of sexual risk detection present in the literature. We saw a trend in the past literature that represents the algorithmic advances on sexual grooming detection, which is an important issue to tackle, but also demonstrates the overlooking of critical sexual risk types that should carry the same weight, if not more in some cases, such as unwanted sexting and sexual abuse. We analyzed papers in terms of their dataset source, type, and privacy to assess their ecological validity of the data. Most approaches only use text data, although other metadata or multimodal data were available. Therefore, we need more multimodal approaches to take the context into account. Our analysis uncovered that papers mostly worked on public datasets, and only a few were using private datasets. The most popular public dataset used in the literature for identifying sexual groomers included Perverted Justice dataset, which is based on conversations between convicted sex offenders and volunteers acting as minors. Research has shown that the writing style of the adult volunteers acting as teens is different from real teens. Therefore, they lack ecological validity. and are not representative of the users, particularly adolescents, who are most vulnerable to these risks. There needs to be more realistic datasets for targeted populations. In terms of ground truth annotations for the dataset, most of the studies relied on existing annotations that were done mostly by researchers without domain expertise, as illustrated on this table. Most of these third-party annotators were researchers that did not have a special expertise on the matter. Therefore, future works need to include more robust processes for annotations and incorporate perspective of individuals who experienced the risks. The most commonly used features by papers were textual or lexical features. Therefore, more behavioral-driven features should be used in the future. We observed trends in terms of approaches used by sexual detection literature, which are demonstrated in the figure. We found that most approaches are based on traditional machine learning algorithms rather than deep learning models. Most of the studies that we reviewed focus on detecting and differentiating predator users and victims after the fact. Therefore, future work should be taking more nuanced approaches to identify problematic patterns that could be used to prevent victimizations before it occurs. Most papers used binary classification setting, where they were usually classify conversations as predatory or not, and users as predators or victims. For a complex problem such as identifying sexual risks, there is a gap of having more sophisticated systems that could have multiple classes based on the patterns of communications and levels of risks. A common theme among the sexual detection approaches was that they came from a purely computational perspective and failed to incorporate any aspects of user-centered design or needs analysis. The articles did not include formative or summative user evaluations of the solutions developed. Instead, the majority of the papers reported computational evaluation metrics to demonstrate the performance of their risk detection models. Although the current computational evaluation metrics are effective in the sense that they show computational performance, they could be further strengthened by assessments through user case studies or error analysis with examples. In addition to the algorithm evaluation metrics, it can be valuable to conduct user studies to evaluate the feasibility of the models in real-life scenarios. We encourage future research to go beyond creating algorithms to developing technologies similar to how they would be used in practice. The majority of the studies fell short of implementing the algorithms in real-world systems or applications. To date, the primary focus has been detecting online sexual predators to help law enforcement agencies identify and prosecute sex offenders. Although identifying predators is an important task, future research should consider identifying behaviors or indicators of being a victim of sexual risk. Without applying the human-centered lens to the context of sexual risk detection, many of our insights would have been overlooked. Therefore, other researchers could use our human-centered lens for reviewing the computational risk detection literature beyond that of online sexual risk detection. Moreover, it's important that researchers and practitioners respond to the call for the need to add fairness, accountability, transparency, and ethics from the points of view of a human observer to explain the reasons behind decisions or the processes that generates them. We call on the community to design and develop human-centered solutions to address these gaps by considering the stakeholders at all stages of designing and developing technologies that bridge the socio-technical gaps for risk detection. Thank you so much for listening. If you have any questions, please email me at afsaneh.razi@nights.ucf.edu. And for more information about our research, please visit our website at stirlab.org.